Today I'm going to be discussing and explaining my Spring Tutorial 3 application. Cool, let's jump into it. So with this application and this tutorial is basically a Spring Boot REST API. It manages running activities and user data, right? So it provides endpoints to create, update, delete, and query specific runs. So like actual runs that you do outside with details like title, distance, duration, and location, while enforcing validation rules such as ensuring a run's end time is after its start time. So runs can be stored either in memory or in database using JDBC. In addition, the app integrates with an external API, JSON placeholder.typecode.com. So we use an external API to fetch user information. So it's like sample data essentially. So altogether, it demonstrates clean architecture with repositories, controllers, and clients, making it a solid foundation for tracking fitness runs and connecting them to user profiles. So it's basically users creating specific runs that they do on a specific day, and then they set like the duration, the type of run they did, the time, as all those fields, and yeah, you save that, or those that data is fetched from a specific APIs and so on. Cool. So let's start off by explaining the application.java, which is the main program that runs. So it's the entry point of the program. So let's see that. So over here, I have my application class. As you can see, we're using Spring Boot application annotation, which marks this as the main Spring Boot application. So it scans all the code in the package, and initially, it just runs the application when we run the main method. Over here, it uses user HTTP client method here to register an object to inject user HTTP client wherever needed, right? And it does that here with this create method here. This is the external API we use to fetch the user data, essentially. So yeah. Then we have in our run package, we have run JSON data loader.java. So this loads initial run data from runs.json as startup, and likely uses add components and post construct as well. So let's discuss this file over here. Um, so as you can see, we have run JSON data loader. So initially, this is basically just gonna load data when the application runs. So here you can see the declaration of the class. So what this class does is it's a Spring managed bean, and here we basically gonna print info to the console essentially. Um, then run JSON data loader is the constructor injection with qualifier to specify JDBC implementation. So then we have the run method over here, which is initially what loads the data if the repository is empty, specifically when the application starts. So that's what that does. Then we have run.java. But coming back to this, how it loads that data is it loads this JSON data essentially. So it loads all these runs. So as you can see, this is JSON formatted data in a specific structure, and these are each of this is a document representing one run, as you can see. So it loads all that data when the application starts. That's what this run JSON data load class does. Then we have run.java, right, which is the code model representing a single run. So it has all the fields for a specific run, right? So when I say a specific run, meaning one specific run, as I highlighted over here. So we have that here in this run package. Um, so over here we have public record run. So this is run as a record. So it's a compact way to define an immutable data class. So this data doesn't change essentially. Um, or the fields, you can't change the fields. So firstly, we have the integer ID, the ID of the run. Then we have the title, the date that the run started. So essentially the time that the run starts, the time that the run ends, so the end time for the run, the miles, and the location. Then we have this run method, which is a compact, well, this is a constructor, sorry. This is a constructor which validates the completed on is after started on. Then here we have this get durations method, which calculates the total duration of the run because it takes the time the run started on and then the time the run ended, as we have declared those fields over here. And it calculates the duration of that time by saying duration dot between. Then here it's just gonna calculate the average pace, minutes per mile essentially. So that's what this run class does. Then we have the location.java class, which is another model. So it's an embedded or related model used inside run to represent geographic data. So it's representing the location of the specific run takes place on. So if we go back to our JSON, we can see here we placed location, right? This is indicating whether the run was outdoor, indoor, or for instance, here in this specific run, the location is outdoor. So what location is representing is whether it is indoor or outdoor, the location. And we do that using an enum. So we say public enum location and then the two locations over here. So that's the location.java. Then we have the run repository.java. So um, knowing that it's a repository, we know that it's going to interact with the database. And there's specific methods that a repository uses to interact with the database, such as find all, find by ID, and all of that. So this is going to interact with the database to get specific runs by fetching all the runs, by fetching a specific run by ID, and all of that. So it may be implemented by either JDBC run repository or in-memory run repository. So if we go to run repository, we can see that there are specific methods that are declared in order to interact with the database to fetch specific runs. So over here we have find all is going to retrieve all the runs. Here we have find by ID. It's going to find a run by its ID specifically. Uh, Here we have create a run, so it creates one specific run. So when a run is created, what happens is it's like creating a new JSON formatted collection. Let me say. So for instance, you could create another JSON collection where, say for instance, the ID is 11, the title is morning run, it has a different time that the run took place, the different miles and location. So that's what the create method essentially does. Then we have the update method, which is obviously going to update an existing run by its ID. And notice when we make all these specific requests, we do them by accessing that specific data with the specific ID essentially. So here we have the delete method, which deletes a specific run by its ID. Then we have this count method, is going to count the total runs stored. Save all saves multiple runs at once. And then this is to search for a specific run by its location. So let's say on the application, I want to search for runs that have a location of indoor only, not outdoor. Once I search it, then it will return only the runs that have a location of indoor. So that's what find by location does over there. So that's the run repository. Then we have in-memory run repository, which stores and retrieves run data in memory. So that's this repository right here. Cool. So here you can see we declare this variable log. Um, then here we have the specific runs. So it's an in-memory list to store the run objects. This find all method returns all the runs. So for instance, it would return all of these runs over here that are in the application. Then we have find by ID method, which is going to find the run by its ID, as well as throw an exception if the run is not found. So that's what that does. And in order to do that, we change the runs, um, which is declared over here as an array list. We change it into a stream so that we're able to use the filter method to filter the runs by ID to find the first run, and if that's not done, it throws an exception. We have a create method which creates and adds a new run essentially. And we can see here we declare this object, um, new run, and you can see all the fields that are declared as well. And it adds the new run to the existing array list. Then we have the update method, which updates the existing run by replacing it in the list. Delete method deletes a run by its ID, and it removes it from the runs array list because it stores all the runs. This count method counts the total runs stored. This is to save all the runs, to find the runs by its specific location. And then you have this init method which runs after the object is initialized. So yeah. Then we have the JDBC run repository um, clause. So this connects to the actual database using Java database connectivity, and it executes SQL queries defined in the schema. So this is the actual SQL queries that we see in this clause. So we have JDBC run repository. So as you can see here, we first declared JDBC client. So it's simplified JDBC client for SQL queries. Then we have JDBC run repository. This is a constructor, as you can see. Um, and then we have find all method. This is going to retrieve all the runs from the database. How it does that is uses SQL queries. So we can see a select star from run. Run is basically what stores all the specific runs in the application. So that select method gets all those runs initially using the find all method. Then we have find by ID. So we can imagine if find by ID is used, we're going to find a specific run by its ID. So with the select statement, you'd select the specific field that you need. So select all this data from run where the ID is equal to, for instance, 5. Then it returns that specific run with the ID equal to 5. Create method. Create method goes hand in hand in terms of SQL, goes hand in hand with the insert into method. Why? Because we're actually adding data to the database essentially. So we say insert into run, and then we insert the data with its fields and then the values essentially. Then it adds that specific document or that specific data. Then we have update an existing run by ID, which is going to just edit an existing run. In terms of SQL query, it uses the update method, as you can see, or the update statement. But because we're updating one specific run, then it will say where the ID is equal to 6, for instance. Then it will update um, this specific run over here, depending on what we're updating exactly. So that's what that does. Delete uses delete from to delete a specific run. count is just gonna select yeah, it's basically gonna select all the runs, and then we use list of rows dot size to determine the size or determine um how many runs are in the database. And then this is saving the multiple runs. This is finding a run by location. Hence why we say where location is equal to um outdoor or indoor, for instance. That's the JDBC run repository clause. Then there's run not found exception, which is just handling exceptions in case we don't find a specific run. So if a run is not found, it just says super run not found. So because it's a constructor, it sets a default error message to the string over here. So yeah, and it's basically a HTTP 404 to the client error. That's how it handles the error of not finding a specific run. Then we have the run controller. So with the run controller, it's a REST controller exposing endpoints such as runs or runs forward slash ID. So it's declaring the endpoints that we are requesting to in order to fetch data essentially. So let's have a look at that. So you have run controller. Um, and this is over here you can see. Well, firstly we have this annotation REST controller which marks this class as a REST controller. Then a request mapping is pointing to this base URL. So this is our base URL for all the endpoints in this controller. So this controller is handling requests that have to do with specific runs. So if you want to fetch specific runs and all of that, like I explained now. So API forward slash runs is our base endpoint. And we have this constructor, run controller. So here's where we have a get request to find all the runs, and we use API forward slash runs in order to get all those runs. So that's the endpoint we use. Then here we have a get request to fetch one specific run. We say API forward slash runs, then forward slash followed by the specific ID of that run. That's just to fetch one specific run by ID. To create a run, we use a post request, not a get request, right? And we make that post request to API forward slash runs. And I'm gonna demo that in Postman after I explain this. Then to update a specific run, we say API forward slash runs forward slash followed by the specific ID. But the difference is we make a put request, and in the body of the JSON format we change that specific data that we're editing. Then delete is just delete a delete request to the same endpoint. And then search is to basically search a specific run, for instance by its location, and we use this specific endpoint. So yeah, that's the run controller. We have runs.java as well, which is a wrapper class for a list of run objects. So that's over here, and it's basically declared as a record, and it's a wrapper record that holds a list of run objects. So that's what that does. Then we have a user.java. So now we're moving into the external API of fetching specific users in the application, right? Because we use an external API for that. So we have this model user.java. So this we find in our user package over here. So it's just a simple model that shows the fields that represent a user. So the ID, name, username, email, all the way down to company. So that does. Uh, then we have address.java, which is essentially doing the same thing but with the specific address of a specific user. So like the street, suit, city, zip code, and geographic, yeah, nested geo object, essentially latitude or longitude. Uh, we have user HTTP client. So here we have our user HTTP client, which is an interface, right? So it's a declarative HTTP client interface for fetching user data. So how do we fetch the user data? We use a GET request to this specific endpoint. So it's just as simple as /users. And excuse me, it's gonna fetch data from the external API that we're using find all method. And this GET request will be made to this endpoint. If you want to get a specific user followed by /users, we just add the specific ID that we want for that specific user we're fetching. So that's all right. Then we have user REST client, the Java. This uses a REST template to consume REST APIs. So user REST client over here, right? So we add components to create an object. Um, so now this is basically a component. We declare this variable REST client, HTTP client for making API calls. We have user REST client, which is a constructor that builds a REST client with a base URL. The base URL being this external API endpoint that we declare here. That's how we fetch those external users initially to use that data in our application. So we have find all. Find all is a method that is using a GET request to the specific user's endpoint to fetch all the users. Same as find by ID, by fetching one specific user by its ID. Then we have the user controller. So user controller is going to handle requests that have to do with users specifically, like I explained. Um, so we have clients declared here as a variable, which is the dependency for making HTTP calls to external API. This constructor injection is a string provides the user HTTP object. Then we have this GET request to find all the users, and then the GET request to find one specific user. And then I showed the JSON formatted data as well, as we can see over here. Each of this data represents one specific run. So we see here the runs declared here. In this array, we have ID 1, and then it's followed by the title, the date that the run, the time the run started on, the time the run was completed, the miles, and the location. This represents one run. And then moving on to the next one, and to the next one, all the way to here, meaning that we have 10 runs essentially. So that's the JSON formatted data. Uh, so then we have the schema SQL applications property as well. So that's basically the code in our application. So you can see as you make the connections that this is just representing an API and how we interact with the API in order to make requests to specific endpoints to fetch data such as specific runs and to also fetch data such as specific users that are linked to those runs. Cool. So now I'm gonna demonstrate um, how the application works in the back end using Postman. I'm gonna make specific requests to the API endpoints to fetch specific data that is needed. So first test that I'm gonna do is I'm gonna make a GET request to this endpoint API runs. So the goal of this is to get all the runs in the application, right? So in other words, to get all the runs. As you can see, all these JSON formatted runs over here. So yeah, so uh, cool. So firstly, to make that GET request to that endpoint, I would have to declare basically firstly the localhost 8080 because this is where the application is running. And then the base URL, which is API users. And just simply clicking send makes the get request to the endpoint, and so runs. When you make the get request, it returns all the runs in the application, as you can see. So from the first run all the way to the last one. So that's basically successful. Cool. Then the next one will make a specific get request to fetch one specific run from the application. So in order to fetch one specific run, we can already see that we've declared API forward slash runs. So just like I explained, you'll need to fetch one specific run by its ID. So if we can just punch in one specific ID like 5 and press enter, then it fetches that specific run. And you can see that JSON formatted data for one specific run. So you can see the ID, which we declared, which was 5, the title, and all the fields all the way down to average pace. So that's fetching one specific run by its ID. Then we're gonna make a post request to API forward slash runs, which is the base URL. We're gonna do that to create a run. So with the post request, we have to add JSON data to the body. So we're gonna change it to a post request, and it's gonna be made to this endpoint, right? And then we're gonna add the specific JSON format data that we wanna add as a specific run. So just gonna take that as the structure of the format. Then we can create a new specific run. So we declare the ID, we declare, say, the title. So we declare the title, morning run, uh, the specific date, right? So let's say 2025, the miles, which was 20, and then we can say it was an indoor run. So that's the location. So once that's declared, because we have post requests being made to this endpoint, this data, which represents one run, so this JSON document will be added to the database. So once we make that post request, it means it's successful. So just to prove that that data is there, we're gonna make a get request again to runs. And when we do that, if we scroll down, we can see that specific run was added over here. So now we can see that that post request to create a specific run was successful. Okay, cool. Then moving on, we'll make a put request to update a specific run, right? So in order to update a run, we need a put request, but we make a put request to an endpoint by locating that specific run we want to edit by its ID. So let's edit the run that we just added, which is the last one over here, the morning run. So here's the endpoint API runs, and then we can say 11. So we want to edit and change this to a night run, let's say. So night run, and we want to change it to 15 miles, right? And since we updating it, we're going to make a put request to the endpoint with a specific ID, which means we're going to change this specific data, this one here. So you can see now it's changed. We've changed the title and the miles. If you click send, it means it's successful. And just to check that it actually worked, um, make a get request to fetch all that data. And then we can see here, when we go to the last one, it's changed to a night run, and the miles were changed as well. So that means the put request was successful for that specific run. Then to demonstrate deleting a run, we're gonna delete the specific run that we just created. So in order to do that, we just change the request to delete, and it's gonna be to the same endpoint, essentially. So if we just say delete, then we put 11. So as you can see now, it is there right now. But when I make the delete request to the endpoint and I go fetch that data again, then you can see here that that specific last um, run is deleted. Then to show how to search for a specific run by its location, because say you want to fetch the runs that have the location of indoor only. What we'll do is we'll use this API endpoint over here, um, /runs/search, followed by a question mark, and then the location that we place in. So in order to do that, right, just gonna paste this. We declare this endpoint, meaning that we're gonna search for locations that have the name indoor. And once we do that, we, as you can see here, some of them have a different location: outdoor, outdoor. Now it's gonna bring locations that have indoor only. Uh, so, okay, got an error. Okay, cool. So now you can see here, fetches all the JSON formatted data. So all the runs that have the same location indoor, because I'm searching for that location. And then you can also search for specific users. We click here. All the users that were fetched from the external API into the application, we can fetch it with this endpoint over here, and it fetches all the users. So you can see um, the ID, the name, username, email, all the way to address, all the way to the company that the user works in. Then this represents the second user, this represents the third user, all the way till the last user that we have. So yeah, that is basically how the application works in the backend. Um, so it's just demonstrating how we use APIs to make requests to fetch specific runs, to edit runs, to create our specific runs, and to also fetch the users that we initially embedded from the external API. So yeah, that is tutorial 3. Cool.